Okay, today we are going to solve for the sides of a right triangle. And this is a right triangle, right? You don't have to take notes on this. I just want to show you. We already know that if we've got two sides of a right triangle, we can use the Pythagorean to solve it, right? But we're also learning that if we've got, say, one side of a right triangle, but we have an angle, if the angles are 30, 60, 90, or 45, 45, 90, for example, we know we can solve that because they have known ratios. But today what we're going to do is we're going to learn how to solve for triangles that have any angle, like maybe 20 degrees, etc. And that's why we learned what we learned yesterday, which was the trig ratios intro. That was the SOHCAHTOA, right? So now we're going to use SOHCAHTOA learn how to solve for the actual numerical side of a right triangle if we've got at least one side and one non-degree right triangle. Before we do that, we need to do a few review questions just to make sure that you're on top of that before we start the lesson. So you should see the assignment. Okay, so if you've got the assignment, if you don't have it, make sure you get it. And there's going to be several review warm-up questions. The first is go ahead and review another simplification of a radical. There's also two right triangles where you're going to special case triangles. And then finally, we'll review what we did yesterday. It doesn't take very long, but basically it's finding the value of each trigonometric ratio. So you can look at yesterday's assignment. So go ahead and do those problems, and I will come back and show you the solution. So you may want to pause it, try it, check with your table mate, see if they're getting it, maybe help each other out, and then come back and I'll show you the solutions. Okay, so here's the steps for question number one, and I kind of went in this order like that. So I did it kind of the long way. I just started breaking it down by two and continue to do that. I could have looked for bigger numbers. For example, this is divisible by 4 as well. But anyway, so that's the long way to break it down. Starts here, goes through here, and ends up getting 8 root 6 for the final answer. So ask me if you guys still don't understand it. Okay, so here's the solutions. The important thing to know is you should be able to spot that these are right triangles with 45, 45, and basically look at the process here. So please look at that and see how I got the different sides and ask me a question if you got it. Same here, number 3. You should be able to identify that this is 30, 60, 90. So look at this, look at your formulas, and ask me a question if you're not sure how I got these answers here. Okay, so the next thing we're going to do is we're going to look at questions 4, 5, and 6. This is what you did yesterday. Okay, so like I said, you did this yesterday. So I'll work the first one with you and just kind of quickly, just to make sure you get the process down. Step number 1, always write SOHCAHTOA when you're doing these kind of problems, okay? Helps you keep it straight. So what are we doing? We got identified. We're looking for sine is equal to what? Opposite over hypotenuse, okay? Step number 2, we need to identify the sides. Hypotenuse is always opposite of the right triangle. And sine z, so that means we need to identify what the reference angle is, z. So the opposite in this case would be the 15. Only one left is adjacent, so that would have to go there. So opposite in this case would be this 15 over the hypotenuse, which is 39. Then we can reduce. Remember, you can use your calculator. You can go 15 divided by 39 and use a fraction, math fraction thing. We should also know you can divide both of these by 3. That would be 5 by 13. Looks like I'm running out of ink. So that's going to be 5 by 13. I'm running out of ink. Oh, yeah. Okay, so that's going to be 5 out of 13. So go ahead and do the other ones and then come back and you'll see the answers for it. But in this case, it's 5 out of 13 after you reduce the fraction. Okay, so here's a solution for number 5. Look through it, make sure you understand it, and ask me or your classmate a question if you don't understand it. Okay, so here's a solution for number 6. Check it out, make sure you understand it, and ask me if you don't. Okay, now we're ready for our lesson. If you understood what we did in the last 3 problems reviewing, then really it's as simple as that. But now we're going to be actually solving for the sides using the angles. So let's go to page 15. Actually, we need to go to page 17. We're going to start on page 17. Now, the very first thing to realize is we need our calculators. When we had a 30, 60, 90, or 45, 45, 90, we did not need calculators, but any other angles of a right triangle other than that, we're going to need to use our calculator. The first thing you see here is what? It says make sure you are in degree mode. Okay, so make sure you're in degree mode. Oops, sorry. What does that mean? Okay, well, grab a calculator and please do this with me. You need to go over to your calculator and you need to go to mode. And let's see. So you see how it says degree over there? Okay, so that needs to be highlighted. If it wasn't, you could use your arrow keys. So what I'm going to do is I'm going to use my arrow keys. And if it was on, I'll make it go to radian and hit enter, okay? Now it's on a radian. It shouldn't be. So I'm going to use my arrow keys to put the cursor over here on degrees so it's blinking and hit enter. Now there's another thing you can do. You can also look up here on your calculator when you open it. It should say degree. So always check that when you get there. Okay, make sure it says degree because it gives you different answers. Okay, very, very important every single time. Okay, the first thing we're going to do is use our calculator to figure out the sine, cosine, and tangent of an angle. Okay, so the first one we see is 55, the sine of 55. What is that? What does it mean? How do we convert it? So let's get our calculator, go over here, and see how you got the keys right here, sine, cosine, tangent. Well, we're going to go sine, and we're going to type in 55, parenthesis, enter, and boom, there we go, 0.819. So also, if you're going to write these down instead of use them directly, I would say at least have 3 digits after the decimal, so it gets pretty close. So 0.819. Okay, 0.819. Okay, you guys try this, but use the cosine key for that and the tangent for that, and see what you get, and come back and see the answer. Okay, so cosine 60, cosine's right here. Type in 60, parenthesis, enter, 0.5. Okay, so 0.5 for that one is what you should have got. Okay, now we're going to do tangent 30. So we go to tangent 30, parenthesis, enter, 0.577. Okay, so at least 3 digits, 0.577. Okay, so that's basically all there is to it. Okay. Okay, so now we're going to use this information to actually start solving for sides of a right triangle. So let's look at this first example right here. Okay, so now we're going to use trigonometry. So step number 1, right, SOHCAHTOA as usual. And we need to find x, the side of the triangle. Well, the very first thing you need to do, again, realize you've got one side given of a right triangle, and you've got one non-90 degree angle, which is a 32. That angle, that non-90 degree angle, again, remember, is your reference angle. Reference, which is, remember, it's the theta, the generic symbol for it is theta, but we've got the actual number. So we're going to label, so we're going to write this down. Number 2, we're going to label the sides. So this is the opposite, just like we did before, hypotenuse, and what's left over is the adjacent, okay? And so now we need to figure out what x is. So here's an important thing. We need to get the x in the fraction. So we need to figure out which one of these 3 has opposite in it, because we need to use that, okay? So the opposite, this one right here, let me use a pencil or red to really emphasize it. So we're looking for something that's got opposite, right? So this one does, and nope, not cosine, but tangent. So we could actually use either tangent or cosine. Okay, so my computer crashed on me, so I'm having to start over from this point again. I hope that's pretty close to where we were at. Anyway, so here, let me just start fresh. Here we go. Yeah, we decided that we needed something with O, so either sine or tangent has the O right there. So I'm going to use sine, but I'm not just going to use sine. I'm going to use sine 32. So I like to abbreviate it like this. This is called subscript. So sine 32, and of course you can write sine 32, that's fine, but I just abbreviate S32 is equal to opposite over hypotenuse, okay? And we know the opposite is the x from up here, right? So that's equal to that over hypotenuse, which is 13, okay? Now it's sine 32 is equal to x over 13. Well, what we're going to do is we're going to use our calculator to figure out sine 32. So one moment. Okay, so it's on degrees, so we're good to go. I'm going to clear this out a little bit here. And we're going to go sine and 32 parentheses, enter, and we get 0.5299. I'm going to just round it to 0.53 since it's not, so 0.53, but generally I like to leave three numbers, so it would be like 0.52530 if I round up from this number. So let's go ahead and do that. 0.530 equals x over 13. At this point, you got yourself a basic algebra problem, right? So you're going to multiply both sides by 13 to cancel this out. Now here's the thing. Leave this value in your calculator is actually the best, most accurate way to do it, because it should still be in there, and then you're just going to multiply it by 13, right? So it's still in there. I don't need to clear it. I don't need to clear it and then type in 0.5. Can I just leave it in there? And then I go times 13 equals 6.88. Now here you can round it because that's the final answer. Maybe 6.89, I would say. So that means that x is equal to 6.89. Okay. So I want you guys to go ahead and try this this problem right here, the second one, and then pause me and then come back and we'll go over that. Okay, so what do we have? We have an angle here, the reference angle. So that makes, again, put your sides. So that's the opposite. We got the hypotenuse, and we've got the remainders, the adjacent. Now we need to get the x, which is a hypotenuse. So I'm going to look to see. So we can either use sine for the hypotenuse here or the hypotenuse there, cosine. Why don't we just do cosine? What the heck? And we can do either one. Either one's fine. So if we do cosine, we're going to do cosine of the 37, right, is equal to a, which is the adjacent. So that's 11 divided by h, which is x. So here x is on the bottom. I told you it's good to put it on top, but that's okay. We can do it. So we go to our calculator. We get cosine 37. Cosine 37. Enter 0.798. Okay, so 0.798 is equal to 11 over x. Now here, we need to get rid of the x, so we can multiply both sides by x, right? And then that cancels, and then we get x times 0.798 is equal to 11. And so then we'd have to divide 11 divided by 0.798. There's two ways to do it. You can do, here you kind of may need to do it. So I'm going to just do 11. Actually, it rounds to point. Okay, so that if it's 0.7986, this would round to 9. So 0.799. So I'm going to go 11 divided by 0.799. And it's going to get pretty close, 13.76, maybe 13.77. Okay, so that means our hypotenuse is 13.97. And by the way, now that you've got two sides, you can actually use Pythagorean to actually figure out what this opposite side is, but it's not asking for that. Okay, so that's the way this works, guys. So basically, you're ready now. If you understand how to do that, start by writing this out, SOHCAHTOA, and then pick the one that works. But now you're going to use the reference angle they've got, set it up. So you guys go ahead and try your assignment. So the next question is going to be number 7. Try that out. And then when you're done, let me check it and I'll confirm it for you to make sure you're on the right track. But other than that, you're ready to do the assignment. Make sure you enter it in on Canvas and make sure you show me your notes for credit. Great job.